right, up next we have Worldpay coming up to present to us. They're going to be talking about, again, how they used OpenShift as a platform to better enable self-service with their own developer team and create better community and collaboration amongst their group. So please welcome Worldpay to the stage.
Hi, we're from Worldpay. My name is Bernd. I'm running the Kubernetes platform team. Been with Worldpay since 2019. I'm originally from Berlin, Germany, and yeah, worked before for startups and other regulated companies.
Hi, I'm Matt. I've been working in DevOps and platform engineering roles for the past 11 years, now working at Worldpay.
Hi, I'm Michal Umlawski. I'm originally from Poland. I've been working with guys for more than 5 years now. Before that, I was in network engineering space.
So let me go back to January 2020, right before the pandemic, when we basically finished building our platform. We did a talk about OpenShift Hive, which we started using with OpenShift 4 to manage our clusters. It was very funny actually, because back then we had discussions with RedHat UK, and everyone was asking us what's OpenShift Hive, never heard of it. So we will explain in a bit what Hive is and how we use it. This was way before all these Red Hat advanced cluster managers were released, so nothing like that existed when we started our journey in 2019 and finished our build. But what was actually interesting, for us, no one was talking about platform engineering or platform as a product. So we all had to figure these things out ourselves. So, but let me start first, what were the problems we faced in 2019? So we had to deal with infrastructure on-prem changes. In some cases things compute wasn't available, and it took very long time to get stuff built. We were raising tickets for manual changes, and we had to wait for somebody to implement these changes. In some cases there was also lack of experience, Kubernetes in particular, but also OpenShift 3. We were using OpenShift 3. It was running in the cloud, was great, but it wasn't scalable. The issues around deployment and managing it with Ansible was not a great experience. So we had no self-service. We had configuration drift. We had duplication efforts of the inconsistent builds. And more problematic, we had no documentation. Developers had to rely on speaking to fellow teams and engineers how to get stuff done and gather information. So there was too much rumor-driven development, how we call it, basically. And back in 2019, we knew things needed to change. Today, I want to introduce you to Worldpay's platform product, the Global Kubernetes Orchestration Platform, GKOP, how we call it. It's an enterprise platform based on RedHat OpenShift on AWS. It's part of the internal developer platforms at Worldpay. It's highly secure, PCI DSS compliant, and we run a fleet of 28 clusters across multiple regions, which run highly available workloads. So GKOP is our product because it's so much more than just OpenShift. We built a lot of automation around it. So the backbone of GKOP is the orchestration and configuration management what we built back then. So we ask ourselves, how do we do it? How do we run a fleet of clusters and manage them at scale? So we built a custom cluster management, which is based on RedHat OpenShift, the Hive project, what I mentioned before. And we render configuration with sorry, 1 second. Our cluster management basically is like rendering the configuration and like apply this to downstream clusters. 1 second. Today we run like 28 workload clusters across like multiple regions and multiple environments, and we extended like some of the features with custom built operators. So to like render and manage configurations to push them to downstream clusters. To avoid like synchronization failures, we have a capability controller to basically pre-render configurations and apply them to downstream clusters. We follow an ensemble cluster concept. So like sandbox and development clusters are regularly like reprovisioned daily and weekly. And higher environments like stage and prod are like long-lived. In disaster recovery exercises, we like delete a region, rebuild it from scratch, from start to finish within like 1.5 hours. We achieve this because of like, configuration is pre-rendered. When for a cluster comes back online, configuration can be instantly applied. And we do that like by doing weekly platform releases. So we like bundle changes together and promote them from like lower to higher environments. So basically, these environments and clusters are basically just copies of each other. So in that case, we can catch regressions like before it reaches production. So what's the definition of a product or a platform as a product? So what does like, GCOP or product needs to have? So it must be compelling. It like must deliver a great experience. What we want is that the platform is easy for them to use it. It needs to get the job done. It needs to focus on the consumer needs. It doesn't matter if I build the best platform no one wants to use. It requires self-service. Like I need instant feedback for it. I can't rely on someone to create a request and then wait for it that it gets picked up. And like I need to be able to make these changes quickly. The platform must be easily accessible, straightforward design and implementation, and the journey it takes to use the platform. So information and support must be easily accessible, and yeah, so what makes it compelling?
Build a platform developers loved and help them innovate faster. While preparing for the presentation, I found this working principle, and to be honest, I really liked it. This could be our motto for more than 5 years since we started working on this platform. But what the platform needs to be to call it compelling? So first of all, it needs to be feature-rich. Those features, they need to work independently, but they also need to interact with each other. So providing that flexibility to consumers and guidance on how to use those features. Developers, really, they want to develop. They don't want to spend hundreds of hours dealing with different CI/CD teams, integrating with different CI/CD tooling. Platform should come with integrated CI/CD toolset, which will guide developers along the life cycle of building their applications. This platform should come with integrated, built-in integrations with companies' enterprise services. So obviously NTP, authentication endpoints, secret management, certificate management, login. This all should be bundled within the platform. Platform also should be secure. So we live in the dynamic world where the attack surface is expanding on a daily basis. So container runtime security, vulnerability reporting, all these also should be part of the platform, so we could decrease the toil of the consumers who are using it. Platform also needs to be easy to use, so providing how-to guides, example services, step-by-step instructions, because there are teams with different maturity levels. Some of them, they're very experienced, but some of them, they need a little bit of hand-holding. And last but not least, platform needs to be reliable. It needs to handle the load at the peak times. Developers, they need to have the trust that it will work when they need it to work. So how GCOP fits into this? So essentially it has it all. So it's built on top of the underlying infrastructure in the same way as OpenShift is. And it's easy to use and intuitive. It provides a flexible container runtime for multi-CPU architecture. So x86 ARM, as well as Windows. It supports various connectivity options, which then our consumers can simply expose their applications privately and publicly in a secure manner. It also has, it offers observability tuning for end-to-end visibility, provides PCI DSS compliance through tools and integrations like IPS IDS, and 24/7 support through those guys who are here with us. Apart from that, we have a tight integration with AWS infrastructure. So authentication through STS. Essentially, as you know, STS provides short-lived tokens. So the integration from GCOP allows our consumers to access our consumers' resources in their AWS account. So this was a game changer really for us, because they don't need to have credentials embedded as secrets or within their applications, but essentially they can use STS, so it increased the security. Apart from that, we also have some teams who don't want to run another infrastructure as code tools, but they simply want to consume their AWS resources, again, in their AWS account. So this is where app controllers comes in. So they can import and manage their AWS resources directly from our GCOP runtime. Last but not least, operators. So we have third-party operators. So we integrate with different services through mature operators and controllers. We constantly evaluating our operator landscape to see which ones they fit our consumers' needs. But if there are any gaps, essentially we built in-house operators. So we have a team of skilled engineers here with us who can code all of them, essentially. So we can build any operators to fit our consumers' requirements, basically. So through those operators, we essentially extend Kubernetes API. So we all here know Kubernetes became the leading orchestration platform, in large part due to its extendable API, powering distributions like OpenShift. So in the same way as OpenShift extends Kubernetes, we, with GCOP, we extend OpenShift, creating internal developer platform. So, as I was mentioning, some of the operators, they come from third parties, and they provide capabilities like databases, caching, messaging, but some are built in-house. We have one example, providing self-service capability to our consumers. We need to be PCI compliant. So we created egress proxy operator, which allows them to build dedicated egress proxies within their PCI namespaces, which allow connectivity to allowed endpoints. So through those components in our platform, which are API-driven, providing self-service through custom resources and operator, we provide a lot of flexibility to our teams.
This API-driven self-service capability is the glue that brings together all of our individual services and components of our platform into one cohesive product, empowering the consumers to fulfill their own requests. Self-service is a hard commitment for us. We do not do manual changes. Every new addition to our platform must be automated and must adhere to this self-service paradigm. Whether that's third-party plugins or our in-house built Kubernetes operators, all of our API resources must be configured by the end users and validated by a set of best practice rules. We categorize all of our API resources by application or platform. Application teams have permission to directly apply their resources independently and with minimal oversight. Using their own pipelines, the more impactful platform resources must be configured through our shared GitOps repository so that we can review changes and maintain a stable platform. Even still, some of you may be thinking this gives too much power or flexibility to the consumers and increases the application risks. This could lead to vulnerabilities through misconfiguration, which could lead to service disruptions or incidents. Because of these reasons and more, we place strong importance on the validation and review process. This does not mean going back to filling out tickets or waiting for a human to review and approve changes. Instead, we make heavy use of automated validation for both application and platform resources, regardless of how they're applied. This codifies our team's shared knowledge of best practice and review. Our validator service is configured on Kubernetes via validating or mutating webhook configurations, which interact with the API requests, such as kubectl apply. And when a pull request is raised in our shared GitOps repository, that will come through via a webhook, and we'll go to that same validator for review. Going into more detail on the validator, which is our custom operator, there's 5 steps for reviewing a resource change. In the example of Kubernetes requests being made, this would all start with traditional RBAC. Does the user have the right permissions to make these changes? Then the validator, via mutating webhook, might add some sensible default values or make some other improvements, for example, pod topology spread constraints. So we might want to ensure that our consumers are balancing across availability zones, for example. The Kubernetes API will automatically check if the resulting resource conforms to the object schema. That could be a built-in object or custom resource definition. If it conforms, it'll get sent back to the validator via the validating webhook, where we may warn the user if they're not following some best practices, or we may even deny the request if there's no permitted if they're not permitted values. Finally, the resource is persisted and reconciled. This is a dry run example of creating a deployment using kubectl. Because this only creates a basic resource, you can see here we have several warnings that are coming from the validator. These warnings can contain recommendations and links to internal documentation. This is to create more guidance and help. In this case, the deployment was permitted. In other cases, we may deny the request altogether. For example, pod disruption budgets have caused a headache for us in the past when we've been trying to upgrade OpenShift. These can block us from rolling out new versions because we can't evict pods. We now validate those pod disruption budgets, minimum availability or max unavailable fields to ensure that we don't get blocked when doing operations. Going back to the case of a GitHub pull request for those platform resources, when a user opens a pull request in our shared repository, the code owner's file in GitHub will request a review from the validator and a senior engineer from the affected tenancies. The validator will perform steps 2, 3, and 4 for each file in the pull request, checking that the YAML is linted correctly, using kubeconform under the hood to verify it against the object schema, validating or suggesting changes using the same rule engine. It'll then post a pull request review, which either approves request changes or escalates the review to a platform team member. Once the pull request has been approved, it can be merged by the consumer along their own timelines and promoted to production when they need. This is all done through API calls between GitHub and the validator running on the cluster. There's no pipelines involved. Here's a few example screenshots from GitHub. The validator appears as a bot and posts reviews on the PR. In these examples, you can see the pull request either being approved, changes being requested, or where it may have to escalate that review to a human where it can't make a decision. In this case, for example, we've got a new domain being added to an egress proxy allow list. In this case, the validator cannot know whether that domain is necessary or permitted for an application to communicate with. So we need to ask an actual real engineer to make that review. But in most cases, we don't have to do any of our pull request reviews. The final piece of our self-service offering is templated onboarding workflows. This provides consumers with all the basic platform resources needed to get started: namespace, quotas, network policies, all pre-configured and approved with best practices. Coupled with automatic merging, this enables tenants to quickly scale and makes the platform easy and accessible to use.
So when we talk about like making the platform accessible, like we need to talk about like the experience and the journey it takes to use the platform. We need to make it easy to find information. Like documentation must be easily accessible, but also, more importantly, like, supports, and, we have to respond to questions. Like we need to treat like our developers as like internal customers, and like we want them wanting to use the platform. So we need to create like a great like developer experience. For this reason, we built a GCOP free tier version. That's see on top, it notifies you it's an ephemeral cluster. It gets like destroyed and reprovisioned daily. It's just a sandbox environment with like limited features, where everyone at Worldpay can log in. Like everyone with a Worldpay username. So you don't need to get onboarded. You can just like log in and start create a namespace, deploy workloads. So it's an easy way to get started and experiment. So it really helps for everyone who's new to Kubernetes, but also like new to GCOP. What I mentioned, it's not just OpenShift. It's so much more with the self-service. I also mentioned we require like supporting documentation and guides. These things you find in a very simple like developer portal, like which we launched 2 years ago with Worldpay developers, because we were lacking, like central guides and documentation, and launching a portal was, for us a great source where we can, store this information. We followed an inner source model actually for that, so it's not just like run by the platform team. So any developer can like start and contribute. So the portal is basically made and run by Worldpay developers. So you find, getting started guides, like learning materials, but you also find how to get onboarded to GCOP as an example. So, but I think the portal is not just about like, our GCOP platform. It's, it just provides a developer a great source of information, what they need to get their job done. In terms of like developer experience, you see on the right side, we need to understand like, what's the path a developer follows. And like we had a hard time with that because there were lots of like manual processes, and like we tried to resolve these, but we had to map these out. So, and it starts like with how easy it is to get onboarded to the platform, how easy it is to start using the platform, like how I build a new service, how I maintain an existing service. Like the consumer engagement is as well important in that sense. We run like forums, we do like roadshows for like new consumers, but also existing ones. But like more importantly, actually, is because we need to listen to their feedback. Like we need to know like what we need to what we should improve. So these like forums, like consumers can ask questions, but they can also like use our persistent chats if we're not in a forum, as an example. But like more importantly, like we want that our consumers like also influence the platform. So prioritize our roadmap, like features that we should deliver for them, but also things what we can do together, as an example. So OpenShift Windows container support like was a great example of a team wanting to use like Windows containers. So we could not like deliver all these things by ourselves. So the team got like involved in doing the test, the build out of these clusters. But we used the GCOP template for that. We want developers to contribute to our platform, like drive initiatives themselves, like example services, shared libraries, but also like more importantly and like more recently, how to improve like continuous deployment like models. So like using stuff like GitOps. But like also of course we want them to see like value in it and like what we can do together basically. So developer experience is not only about like GCOP, but we're an essential like part of it, how we can offer our GCOP product. So what's next for GCOP? like we run the platform since 2020, so 5 years. Like, you know, we continue improving the developer journey, like reduce blockers, like, or manual processes. Like, we want to, you know, increase adoption, like onboarding more consumers, you know, more services, scaling, but also like utilizing more OpenShift features. So we're very successful with the Windows support, where like more consumers are now asking for like a Windows runtime. But also like, you know, adding like new features, like database supports, Kafka messaging, but also like more importantly, increase our test coverage. So, you know, added systems testing, acceptance testing, but also like more continuous and static testing to make the platform basically more reliable. Yeah, we built a, you know, platform status dashboard, like, which we like continue and extending continuously, basically. But yeah, most importantly, we continue to have fun. Yes, you know, it's a very small team. We love what we do. OpenShift is a great product. You know, Kubernetes is a great product as well. So it's, yeah, we get at least like together once a year, like you see the photo there of us. So yeah, and we really enjoy like working together. So thank you very much for listening. Any questions?
Thank you. Wonderful presentation. Really impressed with the short-lived clusters, you know, 7 days. I have 2 questions. So the first question, when it comes to upgrade or patching all the 28 OpenShift clusters, what approach do you take? Do you repave the cluster? You mean you create a new cluster, you ask your developers to, you know, switch the workload to the new cluster, or do you do upgrade and patching of the existing cluster because you have short-lived clusters?
It's a very good question, actually. I think we have like 2 concepts. We have the concept of ephemeral clusters in like the sandbox and development environment, but we also have like long-lived clusters. So the sandbox re-provision daily, like always like on the same version. If we change the version, we just like build it in a new version. The same as development, which is like done weekly. The long-lived clusters are basically patched every like 3 to 4 weeks. So, and we're always, you know, like first starts the rollout of the new version with sandbox, then development, and then like we slowly like, you know, upgrades the 28 like long-lived clusters with like the normal upgrade process. But we do that, you know, every 3 to 4 weeks basically. So
okay, good. So my second question is, you mentioned all your clusters are PCI compliance.
Yes.
And you also mentioned, you know, your clusters use internal logging. Is that true?
No.
Okay.
So we integrate into like a lot of like enterprise services. So we utilize, you know, like the enterprise logging what we have. So yeah.
Perfect. Thank you.
Yeah.
All right. Thank you very much. Appreciate you all.